In this video, the learner will find the distance between a point and a line. First, we need some background information to remember how to solve systems of equations. Given two equations, the solution to a system is the point of intersection of those equations. So here we have the line 2x minus y equals 9 is the pink line. 3x plus 4y equals negative 14 is the purple line. Where those two lines intersect at point A is the solution to that system at positive 2, negative 5. We can also solve systems algebraically. The first method is by elimination. We are given these equations, 2x minus y equals 9, 3x plus 4y equals negative 14. These are the same equations that we just looked at. First, we would want to multiply 2x minus y equals 9 by 4 so that we can eliminate the y term. Notice now that we have the same value of the coefficient, but they have opposite signs. When we add those two equations together, that eliminates the y term, and we have 11x equals 22. Solve for x and get x equals 2. Now that we have one of the values, we can back substitute and find the y value. So the solution is 2, negative 5, which is what we saw on the graph. We can also solve by substitution. Given these new equations, 2x minus 3y equals negative 2, and 4x plus y equals 24, I can use that second equation to solve for y and get y equals negative 4x plus 24. Now I can use the second equation and plug that in to y in the first equation. Using the expression negative 4x plus 24 substituted for y, we get 2x minus 3 times negative 4x plus 24 equals negative 2. Then we solve that equation for x. So we have an x value of 5. Once we know that x is 5, then we can substitute 5 back into one of the equations to solve for y. We can see here the solution is 5, 4. Here's the graphical representation of that solution. We have 2x minus 3y equals negative 2, 4x plus y equals 24. We can see their point of intersection is at 5, positive 4. We also need to remember how to find the distance between 2 points. In this first example, we're given the points positive 1, positive 5, negative 2, negative 1. You can just use the distance formula and have 5 minus 1 squared plus 1 minus negative 2 squared. Follow your order of operations to find that the distance of that segment is 5. You can also find the distance graphically using Pythagorean theorem. First, draw that right triangle, and then find the length of the horizontal and vertical distances along that triangle. Those will be your a and b values to have 3 squared plus 4 squared equal to c squared. Notice we also have those values in that distance formula, 3 squared plus 4 squared, and then taking the square root of it. I want you guys to find the distance between the points negative 2, negative 3, and negative 4, positive 4. In this picture, we're going to analyze the distances between each of the points down here and point B. We can see the length of AB is a little over 7 units. The length from C to B is 5.5 units. And the length from B to D is exactly 5 units. All of these represent a distance to point B. But what would be the true distance to point B from the x-axis? Which one of these lengths would be the true distance from point B to this line? Well, the distance between a point and a line is going to be the perpendicular distance between that point and that line. So as we look back at that previous model, the perpendicular distance would have been the 5 units. So what we have to find is we have to find the length of the segment that makes that right angle with our given line. This perpendicular postulate says if given a line and a point not on that line, there is only one line through that point that is perpendicular, which means there is only one true distance from any given point to that line, and that's the perpendicular distance. So in this next example, we're going to look at taking that perpendicular distance. I'm given line L that passes through the points -5, 3, and 4, -6, and I want to find the distance to that line from point P, which is at 2, 4. In order to do that, I need to know what this line's equation is, and also the line that's perpendicular to that passes through P. So my first task is to find the equation of line L. So I do that by first finding the slope, and I get a slope of -1. I use that slope of -1 and plug in one of the points from line L. Here we used 4, -6, and we found that the equation was y equals -x minus 2. Next, I want to find the equation of the line that's perpendicular to line L and passes through point P. I know it needs to be perpendicular, so I use the negative reciprocal slope. The slope of line L was -1, so the new slope is going to be +1. And I need that line to pass through point P. So I find the equation of the next line, which will be y equals x plus 2. In order to find the distance from point P to that line, I need to know where this line crosses line L. So I have to find the solution to the system of equations. To find the solution of the system, here we're going to use elimination. So we have -x plus x, which gives us 0, -2 plus 2, which equals 0. So we have 2y equals 0, so the y value of that intersection is 0. Plugging that back into the second equation, we get that the x value is -2. So the solution to the system is that point Q at -2, 0. Now that I know that point of intersection, I can find the distance between point P and point Q using distance formula. So point P is at 2, 4, point Q is at -2, 0, and use distance formula to find the square root of 32. I want you to do these two problems on your own.